basic counting principle and permutations are going to be the beginnings of probability. And what we're going to do is just kind of talk about how many different ways we can organize things. Like this. Let's say a company offers 3 types of snowboards, all mountain, freestyle, and carving, and 2 types of boots, soft and hybrid. We want to figure out how many different snowboard setups the company offers. Now we can use what we call a tree diagram. And with a tree diagram, it basically goes like this. You have this starting point where you have nothing. And I'm going to go to the snowboard company and I'm going to ask for a board. And I have 3 different options to choose from. We could choose all mountain. We could choose freestyle. Or we can choose carving. And no matter which one of those I choose, I gotta make a second choice. I gotta choose my boots, either soft or hybrid. Or here I can go soft or hybrid. Or if I chose a carving board, I can go with soft or hybrid. And this tree diagram tells us how many different options we have. See, because if from this line, this says that I chose an all-mountain board with soft boots. This one says we took an all-mountain board with hybrid boots. And obviously, freestyle and soft boots. Freestyle board, hybrid boots. Carving board, soft boots. Carving board, hybrid boots. All right, so all together we see that there are 6 different outcomes. Well, we have the basic counting principle that can help us with that problem a little bit quicker. Instead of drawing that big old tree diagram, what the basic counting principle says is if one thing can happen in m ways, another thing can happen in n different ways, and the number of ways they can both happen, not can no happen, but both happen, is m times n different ways. So, going back real quickly to this example, if we have 3 different snowboard styles and 2 different boot styles, we can set this up using the basic counting principle. First we'd pick our board and then we would pick our boots. So we have 3 options here for boards and 2 options for boots. Altogether there's going to be 6 total options, which was what we already found. How about down here? In Texas, a license plate is 1 letter followed by 2 digits followed by 3 letters. So how many different license plates are there? Well, let's just think about this. We got a letter, then we got 2 numbers, then we get 3 letters. So, using our basic counting principle, we could pick any of the 26 letters first, then any of the 10 digits, 26 letters, 26 letters, 26 letters. We're going to take all these numbers and multiply them together. So real quickly, just multiplying that in my head, blah, 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 carry the 1, blah, 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 45,697,600 different license plates. Now how about if we don't want anything to be repeated? Well, we set it up the same way. We're going to still have 6 things on our license plate. It's going to be a letter followed by 2 different numbers, followed by 3 different letters. Now the first letter, we could pick any letter that we want. And the first number, we could pick any digit that we want. But now when we get to that second digit, we're not allowed to repeat anything. So let's say I picked a 7 for that first digit. I can't pick it in the next one. So I only have 9 different numbers to choose from. Also with the letters, I've already chosen a letter. So now I only have 25 more that we could choose from. By the time we get to the third letter, we've already picked 2. We can't pick those ones. So now we're down to 24 letters. And we get down to the last letter, we're down to 23 options. So we take this and multiply all of these ones together, calculate it all out to be 32,292,000 different license plates. The permutations is a special name for the ordering of objects, so putting them in order. And let's say that we have 5 different things. Well, maybe 5 different letters. They are A, B, C, D, and E, of course. And we want to put them in order. Now, just like that last example, what I can do is pick a letter to go first. And I have 5 different options that we can pick for that. After we've picked that first one and we move on to the next one of them letters is out of the mix now. So I've only got 4 left to choose from. By the time we get to the third digit, or the third letter, we've only got 3 letters to choose from. And now we're getting down towards the end, and when we get to the last letter, there's only 1 left. So that means that with 5 letters, mixing them up in different orders, there's going to be 120 different ways to arrange them in order. Order. This mathematical construct that we do here, where we take a number and multiply by the 1 less than that, by 1 less than that, 1 less than that, is called factorial. So if we're going to take any number, factorial, we write it with an exclamation point like this. What it's going to be is we'll take that number and multiply it by the next number smaller times the next number smaller. Keep going all the way down until we get to 3 times 2 times 1. Okay. And that's how you find the number of permutations, the number of ways to order an object, is you take all them objects and take that number factorial. So if we have 10 teams that are in the finals of the 4-person bobsled at the Olympics, how many ways could all 10 of them finish? Well, we want to take all 10 of those and put them in order. So we're going to find 10 factorial, which is going to be 10 times 9 times 8 times all the way down to 3 times 2 times 1. All right, and you can plug that in your calculator. You get 3,628,800 different ways. Now what I want you to do is look through your calculator and see if you can find this exclamation point somewhere. It's hidden on TI-84s. It's in the math menu, but it might be somewhere else. Of course, when we're talking about the Olympics, nobody cares about how all 10 teams finish. All we care about is the top 3, the gold, the silver, and the bronze. So how many different ways could they hand out the gold, the silver, and the bronze? Well, let's go back to the basic counting principle. We have gold medal, silver medal, and bronze medal. Any one of those 10 could finish in first place. Then there would be 9 left to finish in second place, and then there'd be 8 left to finish there. So altogether, there's 720 different ways for the top 3 to finish. And this brings us to the number of permutations of n things taken r at a time. See, say we had like those 10 bobsledders, or bobsled teams, and we didn't want to take all of them, we only wanted to take some of them. So instead of doing 10 factorial, we didn't go all the way down to 3 times 2 times 1. We stopped when we got to 8. So that's basically like dividing by 7 factorial. We could rewrite this as 10 factorial over 10 minus 3 factorial. And this is how we're going to take the number of permutations of n things taken r at a time. How we would write it is little n, big P, little r. It means we have n total things, but we only want to take some of them. So n's definitely got to be bigger than r. How we'll do that is take n factorial on top and divide by n minus r factorial on the bottom. So let's say we have 4 songs that we want to put on, or we want to put 4 songs on a CD, but we have 12 to choose from. So we're really going to find 12p4. Right. 12 factorial is on top over 12 minus 4 factorial on the bottom. So it's 12 times 9, not 9, times 11, times 10, times 9, times 8, and I'm going to stop there because that's going to keep going. 8 factorial here. Why don't I just keep going? 8, 7, 6, all the way down to 3 times 2 times 1. And that's going to be divided by 12 minus 4 factorial, or 8 factorial, which is 8 times 7 times 6 times all the way down to 3 times 2 times 1. And see, what's going to happen is all of these in the denominator cancel with all of those. Not all of them in the numerator, but up to that 8 factorial. So really the only thing we have to calculate is 12 times 11 times 10 times 9. And we get 11,880 different ways. When we have repetition, that creates a problem as well. Because let's think about how many different ways could we rearrange the letters of the word I. Well, with three things, there's 6 different ways to do it. We can go EYE, and here, why don't I do this? Make one of these E's blue so that we can see it. Because the other way that we could do it is EYE. We could do E, Y, or E, Y. Or we could have the Y come first, Y, E, and Y, E. And without those colors, without the red and the blue, both of these permutations look exactly the same. Right? And they all would pair up like that. So what we need to do when we're talking about permutations, we want to identify how many unique orderings there are. And EYE looks exactly the same as EYE. Right? So how we would have to do that is if we're going to take all n things, we start off with n factorial. That's how we find a number of permutations. And then we're going to divide off all the things that are the same. So if we have p things that are the same, we would divide by p factorial. And then maybe there's q other things that are the same, so we divide by q factorial. Like in this example down here, we'll find the number of permutations of the letters of the word Miami. We're going to start with how many letters there are total, which is 5 factorial. Then we want to divide off all the permutations of all the things that are the same. Well, there are 2 m's, so we're going to divide by 2 factorial. And there are 2 i's, so we divide by another 2 factorial. So this is 5 times 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Now start simplifying. The 2 times 1's cancel, and 2 goes into 4 twice, so we end up with 5 times 2 times 3 is 30 different permutations. It's a lot to remember, so let's break it down like this. First, we have the basic counting principle. That's the most basic thing. That's where we just multiply and multiply and multiply. And lots of times we'll be able to fall back on this. Then we've got permutations. And permutations is an ordering of objects, so they have to be in order. And that's just going to be our n factorial. If we're not taking all n of those things, it'd be npr. So we'd start with n factorial and divide by n minus r factorial. And if there's any repetition, we're going to start with however many we have, whether it's n factorial or npr. I'll just start with n factorial and divide by all the things that are repeated. There we go.